Live. Hello, how's it going, kiddos? Long time no see. Looks like we're sitting at about 15 people right now. That's not too bad, not too bad. So first thing first, I'm going to talk about the project, and then after discussing the project, we're going to go into series and parallel review, and then we're going to do a little bit of magnetism. So I'm not going to start that until about, we'll start at about 12:05, maybe a little later than that, just to let some more people start flowing in. I don't want to have to repeat the project details multiple times, so I'll wait until a few more people join in, and then we'll all get this started. Meantime, I'm going to go grab more coffee.
Mr. Smith, did you see that Ethan asked if you could do a quick review for the quiz today? What quiz is he talking about?
Yeah, we posted a quiz on calculating voltage and current for parallel circuits and series circuits. It's pretty much just a quiz over what we were doing 2 weeks ago.
Are you going, but you are going to go over that, right?
Yeah, it should
okay.
be part of the review that we're going to do.
Okay, perfect.
Do a review on parallel and series circuits, and then we'll get into it. So Ethan, hold tight. That's part of the review coming up. Hello, Brandy. Got almost 30 kiddos in here. That's good. Jada, you no longer have to post your name. I can see everybody that comes into the live session, and I can see how long you were in the live session. So if you came in for half a second and then left, I will know. But if you came in for 2 hours, I'll see that too. So you no longer have to post your name. I can see everybody that comes in and out. How's it going, Samari? How's it going, Diego? Anonymous, you forgot what we did 2 weeks ago. 2 weeks ago, we were discussing circuits, talking about series versus parallel circuits, as well as how to calculate voltage and current for those circuits. So we'll do a little review on that right after we talk about the project. So we'll talk about the project first, then we'll go into series and parallel circuit review, and then we'll start introducing magnetism. And then after that, it's Q&A for the rest of the time. It's 12:07. What's up, Zamari? You got 36 people in here. Zamari, I don't know what that means. What do you have that's assigned today, Gracie? Well, today we're gonna discuss the project. It's gonna be a summative grade. And then you also have the quiz for this week. So there's the quiz assignment, that's weekly, and then a summative project that we'll be doing 2 weeks. So that's what you got to look forward to today. All right, it's 12:08. We got about 39 people in here. So let's give it 1 more minute. And we will get this going. That's cool, Anonymous. Very cool. Ooh. All right. So let's get this going. So there are a few things that I want to talk about. First off, the summative project. So we are, instead of doing an exam for electricity, we're going to have you complete this project instead, and that'll count as a test grade. So if your test grades are low, you can complete this project in order to bring up your grade. Now, in the email sent out, I did say that the project was optional. You are not required to do this project, but I do highly recommend that you complete it. And if you are failing, it is required. I want that to be clear. If you have a failing grade right now, you are required to do the project. So let's just talk about the project real quick, and then we'll keep going. So this is an electricity and magnetism project. So this will be due April 30th. By the way, this is posted on Teams already, so you can go take a look at it if you want to. So this will be due on April 30th by the end of the day, theoretically your school day. So there is a written report segment. Each of these segments should have its own paragraph. So you're going to explain what your topic, explain the topic you chose. So I have a whole list of topics that you can choose from. The physics concepts that apply, and each equation and diagrams that go with it. So any kinematics, Newton's laws. I mean those are for baseball bat. Obviously, we're doing electricity, so yours will be electrical. Any electricity laws that we've covered. An explanation of the application of the physics to my topic. So, for example, the mass of a baseball bat affects the acceleration, the shape of the bat affects the force, the angle at which you swing affects the displacement of the ball. So basically, how does physics affect your topic? And then, of course, D is what you learned, and E is finally any references that you've pulled for your topic, which you definitely need references. So you also are required to do a visual aid requirement. So I highly recommend that you don't use PowerPoint because there's so many other types of media that you can use. You can use PowerPoint if you want, but you can use Sway, Prezi, or any other media that you want, as long as I approve it first. If you send me an email saying, hey, can I do this as my presentation? I'll look at it, I'll think about it, and I'll tell you yes or no. So slides are limited to pictures and a title only. So basically keep it simple. It does not need a whole lot of stuff. And you need at least 6 slides. Finally, a verbal report requirement. I'm not really sure about this yet. We'll talk about the verbal report requirements more next week. Basically, you have a couple options. You can do it in the form of a video, so you can record yourself going through the presentation, using any sort of social media if you want, TikTok, I don't really care. It needs to be at least 2 minutes long, but no longer than 3 minutes. Students must know the topic and should only refer briefly to note cards. Reading straight from note cards is not good presentation skills. Also, eye contact is it's hard to do right now, especially when you don't have a real audience, but practice makes perfect. So, well, I can answer details on that if you have any questions about it, but that's basically it. So basically there are 3 things that you need to do. A written report, which should have 5 different paragraphs in it. They don't have to be excessively long, but they do need to address the questions. You need a visual aid, so at least 6 slides in some sort of presentation form. And then you have to verbally discuss your presentation. At least 2 minutes. I'm willing to be lenient on that. It can be 1.5 minutes if you want, if you're concise. So, any questions over that? Yes, Jack, it's already on Teams. So why don't we go ahead and pull up the rubric. So the rubric is already on Teams. So you can score a 1 through 4 on each different section, the writing portion, the visual aid, or the presentation. 4 being the highest, 1 being the lowest, okay? So the writing portion is 50% of the grade, the visual aid is 20%, and then the presentation itself is about 30%. I'm not going to go through every single detail on what is in the rubric, but make sure you look at the rubric before you complete your project, and as you're going through it to see what you need. If you don't want a perfect score, go for a 3 if you want. But I highly recommend you look at the 4, you make sure everything is in there, and then yeah, just do the best you can on it. The higher grade you can get on this, the better your grade will be overall in the class. Especially if your grade is already hurting. Okay, so here are the topics. Can you guys see the topics? Is that being shared?
I can't see them.
Okay, I just thought about it. I don't think they saw the rubric either.
They did not. Sorry, I was not aware that you meant for them to.
That's okay. Hey, it's not super important. It's already posted on Teams, so I do want to show the topics off though. Stop sharing for a second. Share again. Project topics. Okay, can you see that? So here are all the project types. So basically what I'm going to do is in Teams, I'm going to, you can edit this in Teams. So basically what I want you to do is just put your name by which topic you're going to do. So each class can do their own, they have their own 28 topics that can be completed. So basically if you choose a topic, just go in, put your name by it, and then somebody else can choose a different one. If there are any issues, I can see who's edited this. I can see who's made changes, so. First come, first serve. Yep. So just go into Teams, find the file, put your name by what topic you want to complete, and that's how we'll choose topics. Hope that sounds good. Any questions? Is this document going to be posted in Teams? It's already posted, Jada. It is already there, kid. Sky, why are you laughing? There's nothing funny here. So, questions, comments, concerns? So the project will be due in 2 weeks, so April 30th. How am I doing, Sky? I'm doing all right. I could use some more coffee. Topic list is view only. Okay, good to know. Let me see if I can change that. Okay, I have no idea how to change that yet.
Hey, Mr. Smith, it's Miss Payton. You need some help?
Yeah, I'm trying to figure out how to make a Word document editable on Teams. It just doesn't seem to be that they can edit it right now.
Where did you upload the document from? Like from your OneDrive?
No, I just downloaded it from my computer.
Okay, hold on.
Maybe.
Do I have access to your Teams?
I'll tell you what.
If you upload the file into files normally, but don't put it under class materials, that should work.
It's not under class materials. I did make sure of that. Class materials is locked. It's under a different file. I don't know why they can't edit it though.
They're able to edit it now, Mr. Smith.
Oh, for real?
Yeah.
Oh, okay.
Yep. They're editing it right now. Yep, they're good.
Okay, cool.
Oh, I think it's something on them. They have to just hit and enable it, and they're
Editing,
fine.
yeah.
Yeah.
See, I knew what I was doing. Kids these days.
So
All
there's a question. Chris Holbrook's asking if you want to address that, Mr. Smith, or I can.
Yeah, so I've made the project optional. The summative project is optional. They don't have to do it. But if you're failing, you are required to complete it. If you want to improve your grade, you can complete the project. Summative grades right now are kind of weird. So this summative project is not required unless you are failing. I just went ahead and just made it optional. Maya, yes, you can redo quizzes still. Just send me an email. Megan, it's in Teams. Go to Files, Teleschool, Week 4. No, if you don't do the project, it's not going to hurt you. It's not going to be an incomplete. It's completely optional. Brain Genie was technically due already, but you can still do it. So just go into Brain Genie, complete it. I'll probably shut it down April 30th along with the project, because that's going to be the end of that unit. So the Brain Genie will stop when circuits stop, basically. Josh, let me take a look at it to see if I can see your name. Topics. Yes, Josh, I can see your name. You are in there, kid. When is the project due? The project and Brain Genie are both due on April 30th. Okay, I will be right back. Just give me 1 minute. Less than a minute. All right, kids. Let's keep going. Let's go ahead and review electricity, parallel circuits, and series circuits. So I'm going to stop sharing that for a second. And now I want to share this guy. Okay. So we're going to run through this PowerPoint. It's pretty quick. It's about 19 slides. I have a Nearpod coming up for magnetism, so this is just a PowerPoint. It's already posted in Teams, so you can go take a look at it whenever you want. So, series versus parallel circuits. Series, like we said, has one continuous path. There are no branching, just it flows through every component in the circuit. So just like these light bulbs over here, goes from the battery, flows through each light bulb, and then comes back to the battery. And of course, we know electrons flow from negative to positive, but we say that current flows from positive to negative. A parallel circuit, on the other hand, has multiple branches. So electrons can flow from the battery through one light bulb and then back to the battery. It doesn't have to go through each individual light bulb. So series circuits, the more components you have, the more resistance. Because electrons have to flow through each component, the more stuff you have in it, the harder it is for them to flow. And the more stuff you have in there, the dimmer the light bulbs will be. But of course, if you want to increase the brightness of those light bulbs, you can just increase the voltage. So increasing the voltage will then increase the current as well. And of course, if one light bulb goes out in a series circuit, the entire circuit goes out. So if there's a break in the circuit turns off. So pros and cons. The more devices or resistors in a series, the less current. Like I said earlier, the dimmer the light bulbs. If one resistor goes out, the whole thing goes out. Resistance, a quick recap on resistance, is the resistance or the pushback of the electrical current. So an increase in resistance will reduce your current or reduce the flow of the electrons. And of course, with a series circuit, in order to find the total resistance, you simply add up all the resistors. Series circuits are much easier than parallel circuits when it comes to measuring resistance, because you just add them up. When it comes to current, the current is the same no matter where you are in a series circuit. So if you're at the beginning of the circuit, if you're in between the two resistors, if you're in between resistors 2 and 3, it is the same current no matter what. If it's 15 amps at the beginning, it's 15 amps at the end. Of course, 15 amps is a massive amount of current. That would probably kill you if you touched that. Depending on the voltage, of course. So current can't just disappear. Since you only have one path, some electrons flow through 1 and then flow through 2 and then flow through 3. Voltage, on the other hand, acts similarly to resistance. Each resistor is going to require a certain amount of voltage, and so you add up, or each resistor is going to take away from the total resistance. So the resistance, or the voltage for resistor 1 plus the voltage of resistor 2 plus the voltage for resistor 3 will all add up to the total voltage in the circuit, or the voltage supplied by the battery. So if you're trying to find voltage here, you have to know either the total voltage or you have to know the voltage for the other components. So here is a nice little chart to show you how voltage acts, how current acts, and how resistance acts in a series circuit. We'll fill out the parallel circuit in just a second. Once again, this is on Teams. So if you're trying to write this down really quickly, don't sweat it, it's already posted. So let's say that we have a little problem here. If we're given a 12-volt battery and we know resistor 1 is 50 ohms, resistor 2 is 100 ohms, and resistor 3 is 100 ohms, can we find the current for the circuit? So why don't we get out a little bit of paper. Can I write on this? I think I can write on this. Come on. That's highlighting. Hang on. Hang on. There's gotta be a pin in here somewhere, right? Not redact. You know, PowerPoint's just gotta be this way. Or PDFs just have to be in this way. Tell you what, I'll just type it in there. So if we want to find the total resistance, once again, total resistance, call this RT. Total resistance is resistor 1 plus resistor 2 plus resistor 3. So basically we'll just do total equals 50 plus 100 plus 100. It gives us a total resistance in this circuit of 250 ohms. So our total resistance in this circuit is about 250 ohms. So if I want to know the current in this circuit, now we have to say, well, what is our formula for current if we know the voltage and resistance? Does anybody remember that? Fill in sign. Yeah, I'm doing that. Oops. So if we know the voltage and the resistance, current ends up being voltage divided by resistance. So if we know those two, we can find the current. So we plug that in, we say 12 volts divided by 250 ohms. Well, that's going off the page. And that, of course, gives us, if we can get a calculator out, because I'm not doing that math in my head. About 0.048 amps. So the current for that circuit will be about 0.04 amps, or 0.05 amps, if you round up. Questions over that?
Good job, Fran. And Janelle.
Yep. Questions? Questions, questions? Right, so the total resistance in the circuit is 50 plus 100 plus 100, which is 250 ohms. So 12 volts divided by 250 ohms will give us 0.048 amps. Does that make sense, Khalil? Is it just the quiz? Megan, where do you think we are right now?
Megan was asking what assignments exactly that they were required to complete. I advised her to look at Teams because it has all of the information.
The quiz, and then the project if you're participating with the project. All right, let's keep going. So, parallel circuits, on the other hand. Parallel circuits can have more devices or more resistors, and it doesn't decrease the current in the circuit. The light bulbs don't go dim because you add more light bulbs. If one resistor breaks, then the rest don't break. So it just, the rest, because they're different branches, will stay lit. However, problems with parallel circuits, current doesn't stay the same for the entire circuit. Once again, it adds up just like voltage does for a series circuit. So it's kind of flipping there. Current is added up or is split between each branch. So energy is used up quicker. The total current increases, and you can actually cause fires a lot more easily with a parallel circuit than you can a series circuit, just because you have so much energy flowing through there. It heats up a lot faster and then catches on fire. So what's better, series or parallel? I wouldn't necessarily say series or parallel are better. It just depends on your situation. A lot of things are wired as parallel because you don't have that decrease in current. But of course, you risk fires. This is why you'll have circuit breakers and fuses in your house, because if it gets too hot, the circuit breaks completely and will just completely turn off. That's the point of a fuse. Toll booth explanation. Adding toll booths to a series increases resistance and slows the current. Adding toll booths to a parallel circuit lowers resistance and increases the current flow. So basically, adding more things actually lowers the resistance in a parallel circuit. Pretty weird. So here is the equation for resistance in a parallel circuit. So once again, we kind of talked about this last week, and I'm not requiring you guys to do any resistance calculations with parallel circuits, but if you needed to in a future class or whatever, if you go into electricity, you'll definitely have to consider this. The total resistance in a parallel circuit is 1 divided by the total resistance equals 1 divided by one resistor plus 1 divided by the second resistor plus 1 divided by the third resistor. So basically 2 resistors in parallel with 4 ohms each, that would end up being, 1 divided by 4 plus 1 divided by 4, which ends up with a resistance of 1/2. So you actually get a lower resistance overall with more resistance, with more resistors in a parallel circuit. It's pretty weird. So in a parallel circuit, all paths are used, but the charge is divided up between each branch, like I said earlier. So the current is divided for each branch in the parallel circuit. So the total current is equal to the current down one branch plus the current down the second branch plus the current down the third branch. So if you have 4 amps total flowing in your circuit, 2 amps would go down one and then 2 amps would go down the other if your resistors are the same resistance. That's key. Voltage, on the other hand, your total voltage is the same for all branches in the circuit. If you have 3 different resistors on parallel branches, then the voltage is the same throughout the entire circuit. So the voltage of the battery, if it's 12 volts, you have 12 volts going down each branch. It's just that straightforward. So here's that table again, except with the parallel circuit completed now. Any questions over that? Ooh. Questions, comments, concerns? So those calculations are what you're going to need to do for the quiz this week. So if you feel comfortable with that, you should be just fine on the quiz. By the way, on the quiz, number 1 and number 2 are exactly the same. So whatever you picked for 1, highly recommend that you put it for number 2. Unless you're just going for the guessing game there. In which case, I guess just choose 2 different ones. I don't know. Don't put multiple answers. Just put the same answer.
Mr. Smith, Grace says that she's confused on how to calculate current for parallel circuits.
Yeah.
And Ethan actually said the exact same thing. Can you explain current a little more, like how to calculate in parallel? So. Yep.
Let's do an example. So let's bring back that thing that we had earlier. So we have our total voltage here, 12 volts, and we have resistor 1 is 50 amps. I'm sorry, 50 ohms. Resistor 2 is 100 ohms. Resistor 3 is 100 ohms. So what we need to do is we need to figure out what is our resistance, or I'm sorry, what is our current down each path. Okay, so it's pretty straightforward. You know the voltage down one path. You know the resistance of that path. All you have to do is calculate the current, because the current for each branch added up together will be the total current in the circuit. So let's do that. Basically, we have to calculate current twice, only because technically we would do it 3 times, but resistor 2 and 3 are exactly the same. So we'll just treat them as 1. So we know that current equals voltage divided by resistance. Sorry, resistance. So let's calculate our current for resistor 1. We'll say current 1 equals 12 volts, because that's our voltage. It does not change no matter what branch you're going down. 12 volts divided by 50 ohms, because that's the resistance for that first branch. So our current down the first branch is equal to 12 divided by 50, which if we pull out our calculator, 12 divided by 50 is about 0.24 amps. There we go. So current 1, or the current going down the first branch, is about 0.24 amps. So let's do current for 2. 2 and 3, of course, are exactly the same, so we'll just do it once. So once again, we have the same voltage going down 1, 2, and 3. So we say 12 volts divided by 100 ohms this time. 100 ohms equals 0.12 amps, 0.12. So the current going down the second branch is 0.12. Of course, that happens twice, so technically I3 would be exactly the same. 12 volts divided by 100 ohms equals 12 amps. So what would our total voltage, or I'm sorry, our total current be for that circuit? Well, all we have to do is add them all up. I total is equal to I1 plus I2 plus I3. That ends up being 0.24 plus 0.12 plus 0.12 equals 48, or 0.48 amps. Wow, that looks really bad. Sorry, guys.
Mr. Smith, Ethan is asking, how would the calculation change if you were calculating current between 2 branches, like down the side of the current?
That would be the total voltage. I'm sorry, the total current. So if you're talking about the current down this branch or this line right here, is that what you're asking, Ethan? This current down this line, because it hasn't gone down any branches, is the total current in the circuit. So that would be 0.48 amps. And of course, over here would be the same. Because once you end up on the other side, it's the total current again. That's not true. Okay, that's not true at all. So right here would be the total current. And then here it would be 0.24 subtracted from your total. And then here it would be the other two subtracted as well. So you're actually losing current as you go further down. I'm sorry, I messed that up. We can double check that. Let's bring up a circuit builder. Okay, I tell you what, let's figure out whether I was right or wrong the first time. So let's just set it up. Got ourselves a battery here. Let's get some wire. Let's get some light bulbs. Let's get 3 light bulbs. Connect here, there, and then connect another one there. Do a connection there. Another connector here. Okay, so this was 12 volts. This was 50 ohms. This was 100 ohms. And this was 100 ohms. There we go. So let's figure out what our current is. So let's grab our little current device here. So the total current, just like I said before, is 0.48 amps, right? And down one branch, or down the first branch, it's 0.24. Down the second branch, it's 0.12. Third branch, 0.12 as well. Now, if we're over here, this part is 0.4 amps. Right here, we're dropping because we've lost current from this first branch. And then, of course, here we've lost current from our second branch as well, so we're down to 0.12. So Ethan, I was right the second time when I said it. Each in-between segment is actually dropping current because now you have electrons flowing from each of these segments. So technically, this branch is an addition of these two together, whereas this one is only this last one. Hopefully that clears that up. So sorry, I was wrong the first time I said it. Questions, comments, concerns? My 46 attendees. Do you guys want to do another example on parallel or series circuits? I can do a complex if you would like. I know I put a complex in there. It's basically you just treat it like a combination of the two. There's nothing special about it, but there's just a parallel and a series circuit within the same thing. So the further you get away from the battery, each segment loses value. Yeah, so basically consider, because this branch right here, this wire is a combination of all the branches. That's the total current going through. But if we're here, this branch is no longer included. So electrons don't have to flow through this part of the wire. They can actually flow through this first branch. And so really, this segment, this wire right here, is only electrons flowing through the second and the third resistor. So that's why it decreased in current, because we lost some of the electrons. Whereas here, these are all three branches combined have to go through this wire in order to get back to the battery. So that's why you decrease current as you go down this wire. It's basically, this is the circuit, this is these circuits, and then here is all three circuits. Hopefully that clears that up. Any other questions? Questions, comments, concerns? We are just about to go into magnetism if there are no other questions. I had very little participation in the assignment for last week for the FET program, so I highly recommend that you go back and you do it. Let me know if you have any issues, because I posted a video of me walking through how to build a circuit on YouTube. Okay, if there are no other questions, I'm going to go ahead and switch it over to the Nearpod. See here. Here we go. So here's the Nearpod code. Miss Allie, could you go ahead and put that code in the Q&A so they can all see it?
Yep.
Awesome, thank you. Ooh. Will instructions be on Teams for the project? Yes. The everything I've already gone over is already posted on Teams. So the project description, which has all the instructions in it, the project rubric, and the project topics are all posted in Teams already. So review all three of those. If you still have any questions, send me an email or post something in Teams, and I will answer your question. All right, let's see how many people have joined. Not bad, 12 people. Got about 20 people in Teams right now, or I'm sorry, in the Nearpod. See if we can get just a few more. $26 people. Okay, the best of the. Should probably go ahead and get started. The code is in Teams, and I'm sorry, it's in the Q&A, and it's also right up in the corner here if you need it. So, I thought this. So, Earth's magnetic field lines. So, Earth has a magnetic field that goes around it. Of course, you know, Earth is mostly made of iron. So, because it's made out of iron, it actually has a magnetic field right now. Now, that magnetic field will actually dissipate over years. Eventually, it'll disappear, just like Mars's did. But for now, we have this really strong magnetic field that covers Earth. So scientists don't know what really caused that magnetic field right now. Probably started when Earth was formed back in the early days of the solar system. But this is kind of what it looks like. It kind of looks like a mess. This is, of course, in 3 dimensions. It's easier to look at in 2 dimensions. But it's not stable. It actually rotates. It's flipping every few million years or so. Like I said, eventually it'll actually go away. But for now, it's actually protecting us from a lot of radiation that comes towards Earth. So there have been at least 170 pole reverses throughout Earth's lifetime. So basically what that means is, so do you see the orange and the blue? So basically those are the North and the South Pole, and they flip every few million years. And so what is the North Pole actually goes and becomes the South Pole, and it just flips. The direction of the magnetic field actually reverses. And it's pretty strange. So the most recent pole reverse was about 700,000 years ago. So where on Earth do you think the magnetic field strength is most intense? So let me see your answers. I'll flip this to something else so you guys don't see each other's answers for right now. So for a moment, it's anonymous. So let's see what people are saying right now. Jack said the core. Sarah said the North or South Pole. Jada said the South Poles. Fatima said the poles. Maya said the North or South Pole. Ethan said the core. Zamari said the poles. On the rotation. Oh, Darian, I don't know what that means. Sarah said the core. Core. Well, it turns out that it's actually strongest at the poles. If you look at, let's see here, does it have, let's go back here. If you look at this, the most magnetism seems to be coming from the poles, right? Or those magnetic lines start from the north and the south pole. So that's where you're going to get the strongest magnetism. So magnetic field lines. So if you have a magnet has a north and a south pole, right? Sometimes you'll see an N or an S drawn on your magnets. That's the direction of the magnetic fields. So it starts, or the magnetic field starts by coming out of the North Pole and goes into the South Pole. See, these arrows are going from the north into the south. So that's the direction it flows every time. So you can kind of think of a magnetic field as being the range at which a magnet can pull on things. So if you imagine your arms stretched out, your field is as far as your arms go out. And so you can't reach anything that's outside of your own field. Well, that kind of works for a magnet as well. The magnet can only pull things that are as close as the magnetic field is wide. So magnetic flux, you can see the number of lines is greatest around that pole, right? Right at the tip, that's where the highest amount of magnetism is developed. So the poles of the horseshoe magnet are close together where the field is closer and stronger. So this is a horseshoe magnet, and you can see those lines in the magnet, right? So those lines represent the magnetic field. So here it's kind of odd. You have the north and south pole right next to each other. So you can see it's strongest where those two are close together, and then it kind of weakens out on the edges. So what are the advantages of using a horseshoe magnet instead of a bar magnet? Well, the poles of horseshoe magnet are really close together, and so you can have a very strong magnetic field right there at the end of the horseshoe. So in a bar magnet, that magnetic field is stretched across that area, whereas a horseshoe magnet, it's strongest when you're right there at the two poles. So we can't actually draw on this, so I don't know why it says this, but if you were to draw the magnetic field lines, they would be coming from the North Pole and going to the South Pole, right? Whereas here, they wouldn't really go into each other, right? They would be drawn away from each other because North and South, or opposites, attract and likes repel, right? Similar poles will repel each other. So two North poles will actually repel each other. They won't have magnetic fields going into each other. They'll actually be going away from each other. Kind of like this, where you have that magnetic field kind of repelling away from each other. Whereas here you have the two south poles. We know south poles allow magnetism to come in. It's originating from the North Pole and going into the South Pole. Here you can see those magnetic fields are kind of coming in but away from the other pole. But of course, when you have a North and a South Pole right next to each other, you have that magnetic field coming from the North Pole and going into the South Pole. Pretty straightforward. Any questions so far? So I just realized that when I flip through this, it does not flip through for you guys. I did not know that's how this worked. So I hope you've been following along. But any questions so far, just let me know. Here is Earth. So I want you to draw Earth's magnetic field. Let me see what you got.
Mr. Smith.
Yep.
Khalil is wondering if it'll still count. Will I still count as doing it because the interaction on Nearpod didn't show up for me?
The interaction didn't show up. Well, try refreshing. I don't know what to tell you. I'm not taking this for a grade. I will take it as a participation. I'll dish out Sparta bucks for people participating, and of course you can use those to redo quizzes if you want, increase your grade. So you're drawing the magnetic field. So make sure that you draw arrows showing me which way the magnetic field is going. Remember what we've said about north and south poles. That's just mac and cheese. No, this is fantastic. Very interesting. So we know that we have the North Pole up north and the South Pole down south. Many of us have drawn it backwards, where the magnetic field is going from the South Pole to the North Pole. Isn't that strange? So if you look it up, which I'm assuming a lot of you guys did, it shows the North Pole as the magnetic South Pole. This is because technically the North Pole is a South Pole. Although it's north to us, that magnetic field goes from the South Pole up to the North Pole. Isn't that strange? So this is a little Google Earth. So if you click on it, you drag it around to the back side here, you can actually see the aurora, right? So that aurora is due to the magnetic field and particles bombarding from the sun into Earth's magnetic field. That's what gives it that beautiful color. So you can thank Earth's magnetic field for the auroras up in the north side of the north hemisphere and the south side of the southern hemisphere. You typically don't get auroras near the equator because the magnetic field is weaker around those areas. You have to be near a really strong part of the magnetic field in order to see an aurora. So here's a quick little quiz. And that kind of finishes off what I want to talk about for magnetism. Kept it very straightforward, nothing too complicated. If there are any questions, let me know. Otherwise, that's all I got for you, kiddos. Hope you guys had a great spring break. I know you guys went out and partied, right? Social distance partying. So I'll give you a few more minutes to complete the quiz there. And then we'll talk about it. And then we'll do Q&A for the rest of the time.
Mr. Smith, they're concerned that there's not a picture on the second question. Someone's asking if you could go over how to calculate voltage again. And someone is not allowed to participate in the Nearpod. Well, what do you mean? Okay.
That's a great question. Don't know why number 2 didn't show up. Just go ahead and click something for it. So number 2 doesn't have a diagram, don't worry about it. This quiz isn't for a grade anyways. Otherwise we would be in a lot of trouble. Yes, I can go over voltage again. Elena, I don't know why it's not letting you participate. Try refreshing. Try again. Any other questions? Questions? Okay, let's go over it. See if we can get the quiz to pop up. Anybody get them all right? I just put down random answers, so. All right, so magnetic field lines are drawn, of course, from the North Pole to the South Pole. So from north to south. There was no diagram, so don't worry about number 2. Number 3, magnetic flux is the number of magnetic field lines in an area. It's an indication of the strength of a magnetic field, and it's the greatest at the poles. So all 3 of those. So the flux are those lines coming out, right? Or how many lines are coming out. The cause of Earth's magnetic field, still unknown. Nobody really knows. A giant bar magnet embedded in the center of the Earth. That would be funny. But nobody knows. The Aurora Borealis originates as solar wind from the sun. It's caused by charged particles transferring energy when they bombard the gases in the atmosphere, and are only seen at the northern latitudes. You can see them at the South Pole as well. Of course, they're not called Aurora Borealis, but they're still auroras. And that was it. That was all the questions. So if you have any questions for me, let me know. I'm gonna go ahead and end this. Zamari, the work that you need to complete is the quiz, and if you're participating with the project is worth a test grade. It won't hurt you if you don't complete it, but it will help you tremendously if your grade is low. So if you're sitting at a C and you want a B, do the project. If you're sitting at a B and you want an A, do the project. Samara, I won't let the project bring your grade down. If you do really poorly on the project, or you, I don't know, mess something up, forget about it. I won't let your grade get hurt because of it. I'll only let it help you. That wouldn't be fair. Khalil, is your cat a chicken disguised as a gecko? No, she just looks like a lump of fur, really. Sky, how was Martinique? I haven't gotten to travel anywhere, and I wish I could go to Martinique, but it's you know, the whole Corona thing. Just asking for research purposes. Mm-hmm. Yes, Samara, your grade can't hurt because you do the project. In fact, I don't know if you guys heard, but Miss Allie, we're telling them about the whole March 12th thing, right?
Oh, yes. And we had a, let me, you know, do you want me to share my screen? This is the announcement that we did in biology, and Ms. Payton came on and she okayed it. They're actually going to send something out to it today, so I can share my screen, like, so that they can see it. Yes? Yep. No? Okay. All right. All right. Share. Okay. So, oh gosh, sorry. Hopefully you guys can see this. It just clarified grade freezing. I know that some teachers sent out some emails, but if you do not participate in Teleschool, you're going to receive an I or an incomplete. All right, so there is a March 12th, there's a grade, whatever grade you had in your class as of March 12th. If you were failing, participating in Teleschool is going to allow you to recuperate that grade as long as you do everything and you talk to your teacher and stuff. If you were passing, okay, your grade will not go down, it can only go up. But it's not going to stay the same if you don't do anything or if you don't participate in Teleschool. You still have to participate. So if for some reason you don't, you'll receive an incomplete and you'll have to make up that incomplete grade either in summer school or by taking the class over again, regardless of the grade that you have for March 12th. I hope I did not confuse you anymore.
Thank you, Miss Allen. Questions, comments, concerns? I'm here until 12 or until 2, so let me know.
Mr. Smith, I'm gonna head out so I can get ready for my next meeting.
Sounds good.
All right, if you are on here and you are my student, please, 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 please check your email later on today. I'm going to be sending you some information. Thank you.
See you, Brandy. Have a great day. What's up, China? No, I'm not going to listen to Playboy Cardi live. It seems weird. Can you go over one of the questions on the quiz, or at least how to do them for this week? Yes, I'm more than happy to go over how to do some voltage or current calculations. I can pull that power up or the PowerPoint up again. Janelle, yeah, you can leave if you don't have any questions. I'm not holding you here hostage. China, if you're having trouble putting your name on something, just send me an email on what topic you want to do, and I'll put your name in there. Sarah, do you have any specific questions that I can cover? Because I'd rather not go through all of parallel and series circuits again. If you have any questions on how to do a specific calculation, because you're basically, for this quiz, you're just calculating current or you're calculating voltage for series or parallel circuits. So are one of those confusing you? Because I can cover it. I just need to know. No, the project is not mandatory, but I highly recommend you do it if you want to boost your grade up. Counts as a summative grade, and it can only help you bring up your grade. It is mandatory if you're failing, though. So if your grade is below a 70, you are required to do the project. See you, China. Have a great day. See you next week. Taylor, yes, I'm gonna post the video of this on YouTube, and you can go to my YouTube channel and watch any of those videos anytime. You just have to wait until the live session ends, and then I'll upload it. Sarah, you're not sure how to fully do voltage calculations? Okay, so I'll do a voltage calculation for a series circuit and then a parallel circuit, okay? So let me just throw something up real quick. Where is it? Okay, so here's a series circuit, or I'm sorry, here's a parallel circuit right now. So when it comes to a parallel circuit, the voltage is the same no matter what branch you're going down. So if this battery is 12 volts, the voltage for this path, and here we'll grab a voltmeter. If we want to know the voltage across this light bulb, well, that's the same as the battery because the voltage is the same no matter where you are in a parallel circuit. So let's measure this light bulb. Oh, it's 12 volts. If we measure this light bulb, it's also 12 volts. So no matter where you are in this circuit, it's always 12 volts here. However, if we start over, say we clear everything out, and we build a series circuit instead. Let's put 3 light bulbs in here. In fact, I'll even show the value so you can see it. So I hook up all the light bulbs directly to each other, just like this. So the voltage in a series circuit depends on where you are in the circuit. So really the best way to do this is 1, find the total current in the circuit. So we know our battery is 9 volts and we know the resistance of each light bulb. I'm gonna change this to simplify numbers a little bit. So a 10-volt battery, let's do, let's make this light bulb 5 ohms. Then we have 10 and 10. Oops. 5 ohms, 10 and 10. So if I wanted to calculate the voltage across each light bulb, first I need to know the total current in the circuit. So total current is going to be the same, or the current is the same no matter where you are in the circuit. So really all we have to do is find the total resistance and calculate current equals voltage divided by resistance. I wish I could draw on this. Let's see here. I got a board right here. So if we've got $10 volts, 5 ohms, 10 ohms, 10 ohms. So this is our circuit, right? Wow, that is really awful, but whatever. So that's our circuit. Our calculations, all we have to do, add up. If we want total resistance, all we have to do is add up all the resistors together. So we say 5 ohms plus 10 ohms plus 10 ohms. And that'll give a total resistance of 25 ohms. So the total resistance in our circuit is just 5 plus 10 plus 10. That'll give us 25 ohms. So our total voltage for the circuit is 10 volts. So voltage equals 10 because that's the voltage of our battery. Our total current is dependent on the resistance and the voltage, and we say current equals voltage divided by resistance. Just like that. So current, right there, current is equal to voltage divided by resistance. Our voltage is 10 volts. Our current is 25. I'm sorry, our resistance is 25. So we say 10 divided by 25 will give us a current. Let's see here. 10 divided by 25. So our total current for this circuit is 4 amps. So no matter where we are in the circuit, our current is 0.4 amps. Okay? However, if you want to find the voltage for each light bulb, you take the current, the total current, which is 0.4 amps, and the resistance of that light bulb, and the voltage across it is just voltage equals current times resistance. Just like that, voltage equals current times resistance. So for light bulb number 1, our voltage is our 0.4 amps times 5 ohms. Just like that. 0.4 amps times 5 ohms. And that will be two. Sorry, that shouldn't have taken me so long. So the voltage across the first light bulb, this guy, is 2 volts. Of course, you can do the same for the other 2 light bulbs. So let's bring it back to this guy. So the voltage across this light bulb right here is going to be 2 volts. Oh, here, you just got to switch these. Look, so the voltage across this light bulb is 2 volts because our current, which is 0.4 amps times 5 ohms, will give us 2 volts. Of course, if we do 0.4 amps times 10 ohms, we get 4 volts instead. And of course, that's the same for this guy, 4 ohms, or 4 volts. So 4 plus 4 plus 2 will give us a total of 10 volts. I don't know if that cleared things up, Sarah, but basically when it comes to voltage in a series circuit, each resistor has its own amount of voltage that it pulls. And when you add up the voltage for all the resistors, it should be the total voltage at the end of, or the total voltage coming from the battery. Adrian, I'll fix grade, or Adrian, I'll fix the grade when I have a chance. Natalie, I emailed you about this, but I did the quiz earlier. I'm pretty sure the quiz was the same for 1 and 2. I'll look at it again. Sarah, do you have any questions about voltage? I don't know if that actually cleared anything up. Just let me know. let me know if you have any questions. I am here until probably 1:55. Questions, kids. Anything at all. My 14 kiddos are just hanging out. Wow, that's so strange. Grace, I'm looking at it right now. There seems to be something weird going on with forms. My form, it shows one of the questions repeated, but the one I attached to the assignment is actually fine. So all the questions are different. 2 and 3 are not the same. If you look at it, 2 is asking for current 1, 3 is asking for current 2, although the answers are similar. So it turns out the assignment's actually fine. The quiz is fine. Complete it just the way it is. Sorry about that. Okay, I'll be right back. All right. Any last minute questions? Last minute questions. Is everybody doing all right? Any issues? Anybody want to know people that have the coronavirus? Any protests? Yeah, my cat is she's pretty chill. She needs to go on a diet though. Daniel, your friend has symptoms. It's kind of scary. Thankfully, people that are young seem to be doing all right. Although it seems like some 102-year-old person recovered from corona. It's pretty cool. All right, kids. Well, if there are no last-minute questions about physics, it's about 1:52 now. So I guess I'm gonna hop off. You guys stay safe. Have a great week. See you next week. If you have any questions about the project, send me an email, and I'll make sure things are going. All right. See you guys later.